Hello and welcome to this video. In this video, we will continue the JSON functions and operators, and we will resume where we left off. So we had covered up to this table of functions and operators. So we have to read the note in the last video we left here. So let's get started without further ado. The result type of by the way, before starting, I would like to say that if you have not watched previous videos in this playlist, then please take some time out to watch those. Otherwise, you will have difficulty understanding a lot of stuff which is there to come. So we continue. The result type of the datetime and datetime template methods can be date, time period, time, timestamp period, or timestamp. Both methods determine the result type dynamically. The datetime method sequentially tries to match its input string to the ISO formats for date, time period, time, timestamp period, and timestamp. It stops on the first matching format and emits the corresponding data type. The datetime template method determines the result type according to the fields used in the provided template setting. The datetime and datetime template methods use the same parsing rules as the to_timestamp SQL function does. See section 9.8 with 3 exceptions. First, so if you want to see section 9.8, we had covered this earlier. So we go back. Yeah. First, these methods do not allow unmatched template patterns. Second, only the following separators are allowed in the template string: -sign, period, solidus, or slash, comma, apostrophe, semicolon, colon, and space. Third, separators in the template string must exactly match the input string. If different date or time types need to be compared, an implicit cast is applied. A date value can be cast to timestamp or timestamp period. Timestamp can be cast to timestamp period and time to time period. However, all but the first of these conversions depend on the current time zone settings, and thus can only be performed within time zone aware JSON path functions. Let me see if sound is getting recorded. Yeah. Similarly, other date or time related methods that convert strings to date or time types also do this casting, which may involve the current time zone setting. Therefore, these conversions can also only be performed within time zone aware JSON path functions. Now we will study this table, which shows available filter expression elements. Table 9.53 is named JSON path filter expression elements. So first is value is equal to value, which returns a boolean. It is an equality comparison. This and the other comparison operators work on all JSON scalar values. So the JSON value which we have is this array. First element is 1, then a within string, it will form a string 1 and 3. And then we are comparing this for each element. Dollar is the root and bracket means array and star means each element. We are comparing if it is equal to 1. And if it is equal to 1, it will be returned. So first and third item will match. So we'll get 1, 1. The second example, JSON-B example, both are JSON-B example. So at the rate is compared to A, and that's how we have got A in the output. Then not equal to or less than greater than. So it will behave like previous one. If we say at the rate not equal to, then 2 and 3 will be selected. If we say A at the rate not equal to B, then A and C will be selected. Then less than comparison is there, value less than value. So here at the rate should be less than 2. So only 1 will be returned. Then less than equal to. So here we chose B. So A and B will be returned. Then value greater than comparison. At the rate greater than 2. So 3 is returned. And greater than equal to comparison. Greater than equal to 2 is specified. So 2 and 3 are returned. Then true. It is JSON constant true. So here we have JSON, which is an array. First element is name John, parent false, then name Chris, then parent, true. So there are two elements, John and Chris. John's parent is false and Chris's parent is true. Now we are testing for at the rate parent is equal to true, which is true for Chris. So Chris and parent true is selected from the array. Then we have false, boolean constant false. So this time John will be selected. The example is same. Then we have null, which is JSON constant null. Note that unlike in SQL composition, two works normally. So we have one element Mary and job is null. Then we have Michael and job is driver. So we compare job with null dot name, then we get Mary because job is null for Mary and we are selecting name after that. Then we have boolean and, so it is AND gate will be the logical AND gate will be created. So at the rate should be greater than 1 and less than 5. So 3 is the value which will match and it will be returned. Then we have boolean OR. So in this case less than 1 and greater than 5 should be selected, or less than 1 or greater than 5 should be selected. So we will get 7. Then we have not boolean, the not get. So 137 is there and we compare that it should be less than 5 and then we apply not get on this. So essentially it should be reversed. So it would be at the rate greater than 5, greater than equal to 5. Yeah. So it will become a normal greater than equal to 5 and that is what not gate will do. And that's how we get 7. Then we have boolean is unknown. Then we have at the rate greater than 0 is unknown and will return foo because you can't compare foo with 0. Then we have string and like underscore regex, which is a string, and then we have some flags. Tests whether the first operand matches the regular expression given by the second operand. Optionally, with modifications described by a string of flag characters. So first our operand is an array here, ABC, ABD, ABDC, and so on. And then we are comparing with like regex, and we have that it should be starting with AB, then 0 or more characters, and then C should be there. So this will match, okay? And this will not match because we don't have C after AB, because dot star means 0 or more. Then we have ABDC. So ABDC will not match, okay, because D is there and dot means it should be repeating. Then we have ABDACB. So these are all small case, it should match. Now in the other example, the flag I is mentioned. I do not remember flag I, it is for case sensitivity, I guess. So since case insensitive match has to be done, what will happen is that ABDC will match because case will now won't matter here. Because of case, this did not match. This B did not match this B. Okay, that is why this was not selected. Then we have string starts with string test whether the second operand is an initial substring of the first operand. So in the array we have John Smith, Mary Stone, Bob Johnson, and we are comparing filtering based on starts with John. So first will match and second and third will not match. So John Smith is what is returned. Then we have exist tests whether a path expression matches at least one SQL or JSON item. Returns unknown if the path expression would result in an error. The second example uses this to avoid a no such key error in strict mode. So we have this JSON, we have two properties X and Y, and X has value of an array 1, 2 and Y has 2 and 4. So we take every item and it should be greater than 4. So the second element of the object matches, that is the value of Y, and that is returned. Now in this case value is 41 and we are checking whether name key exists or not, which does not exist. Okay, and that's why we have empty array. And the second example uses the exist key to avoid no such key error in strict mode. Now we will move on to SQL JSON regular expressions. So you saw that we use some regular expressions here. So we will study the details of this. SQL and JSON path expressions allow matching text to a regular expression with the like regex filter. For example, the following SQL JSON path query would case insensitively match all strings in an array that start with an English vowel. So you see, it will match A, E, I, O, U, and I flag means case insensitive. The optional flag string may include one or more of the characters I for case insensitive match, M to allow caret and dollar to match at new lines, S to allow dot to match a new line, and Q to allow the whole pattern, reducing the behavior to a simple substring match. The SQL or JSON standard borrows its definition for regular expression from the like regex operator, which in turn uses the XQuery standard. PostgreSQL does not currently support the like regex operator. Therefore, the like regex filter is implemented using the POSIX regular expression engine described in section 9.7.3. This leads to various minor discrepancies from standard SQL or JSON behavior, which are cataloged in section 9.7.3.8. Note, however, that the flag letter incompatibilities described here do not apply to SQL JSON, as it translates the XQuery flag letters to match what the POSIX engine expects. Keep in mind that the pattern argument of like regex is a JSON path string literal written according to the rules given in section 8.4.7, which we have already covered. This means this is chapter 8. We have already gone through chapter 8. So again, if you have not watched previous video, you should go and watch those. This means in particular that any backslashes you want to use in the regular expression must be double. For example, to match string values of the root element that contains only digits. So we filter the root elements and like regex. So we want to find only digits. So D plus is what we are looking for. One or more digits, and then backslash escaping is we need two backslashes. Let me see how big is this section 9.16.3. We won't be able to finish this today. Okay, we stop here, and in the next video we'll continue from SQL JSON query functions, and we will cover till JSON table. How big is it? Quite big. So we'll see. We will make some. It is quite big. So we will continue with section 9.15, and we'll see how far we can go to section 9.16. We will go as far as possible. We won't be able to finish 9.16.4, but we'll see. So with this, I will end this video here. I hope that you're enjoying this read through. And at the end of this read through, that is once we have finished all this, I will give a complete exhaustive example. Also, I want to show you my website where you can ask and come. You can come and ask SQL based questions. So the website's name is kunjika.ashtabak.org, and you can use the tag SQL to ask questions to me related to SQL in general. You'll need to make a login, and you will need to make use of one of the tags to ask questions. So YouTube comments are not suitable for programming discussions, so it is best if you can join the website and ask questions directly to me. So thanks a lot for watching the video. I'll see you in the next one tomorrow. Till then, stay curious, keep learning, and most importantly, enjoy.